Okay, my name is Richard Pickering, and I'm making this video for educational purposes. And this is actually a video that I want to make. So yeah, I'm actually pretty excited about that. This video is off of different subjects from my regular videos, and ultimately my aim in this video is hopefully to just spark some interest in a subject that I like a lot, and it really captivates me, and I find it extremely interesting, and that's actually just cosmology. It's the study of the universe as a whole, and really just all science. But anyway, I think a good place to start on this subject would actually just be the distance scale of the universe, and a good place to start is just our solar system, because we're given a model, and it's a good model of our solar system, but it's pretty inaccurate with the distance between things, and that's kind of what I want to clarify here and show you, and hopefully spark some interest. And I hope that if you like the video, that maybe you would share it with your children and maybe spark their interest as well. But anyway, I'm going to go to my whiteboard because I think it'll be a little bit better, and you don't have to look at me, and I get to draw, so it'll be fun. Alright, let's see. Let me get squared out. Okay, here we go. Alright, we're going to start out, and we're going to go with kilometers, because when you're dealing with science and math, or really science or astrology or anything, when you're learning like that, you're going to learn in kilometers, so, and not miles. So anyway, we'll just start out with the Earth. And the Earth is a massive object, and it's roughly about 40,000 kilometers at its equator. Roughly, that's just kind of a rough estimate, but that is a huge number. I mean, a kilometer in itself is a pretty long distance. 40,000 kilometers is huge. It's really, really, really massive. The Earth is just a massive body, and it's actually so massive that all the mountains and all the valleys and everything in it, and these huge, like the Grand Canyon and so on, are huge to us, but really on the scheme of things and the size of the Earth, they're really just totally insignificant. I mean, the Earth is so big that if you shrunk it down to the size of a marble, it would actually be smoother than marble, because it's so big that these little hills and valleys and stuff are just insignificant compared to the actual size of it. And that also has to do with the fact that about 70 or more % of it is covered with water. But anyway, it's a huge, massive body. And now I want to move on to actually something else that I want to talk about, and that's the speed of light. And the speed of light is actually, it's a physical law. It's the fastest. Light travels at the fastest speed that anything can travel. The speed of light is the fastest that anything can travel in our universe. That's a law of physics, and actually nothing other than a photon can actually travel at the speed of light that we can actually prove, because it requires a zero rest mass, but I don't want to get into all that. So anyway, the speed of light is 300,000 kilometers per second. Alright, and that's a crazy fast speed. I mean, light travels extremely fast. It's like I said, the fastest speed in the universe. But anyway, in 1 second, a photon emitted could travel around the Earth, could circumvent the Earth and travel around it 7 times in 1 second. So think about that. Think about how massive this body is, the entire Earth. A photon in 1 second will go around the Earth 7 times. That's crazy. That's a huge distance. It's actually, it's 300,000 kilometers in 1 second. But anyway, now that we've clarified that, let's move on to the distance between the Sun and the Earth. All right? And first, some things about the Sun. The Sun is huge. The Sun is massive. The Sun is, you could actually fit 1,000,000 Earths inside the Sun. That's how big the Sun is. The Sun is just a massive object. The Sun is over 99% of everything in our solar system, and all the other gas and all the other stuff, the sun is 99% of the mass. That's how big it is. Alright, and it's in the center of our solar system. But anyway, it's pretty common knowledge, I think, that it takes light 8 minutes to travel from the sun to the earth. So now think about that statement. Think about what we just talked about. In 1 second, light can go around the earth 7 times. It takes light 8 minutes to get from the sun to the earth. So think about that. That's I mean, in 60 seconds, you know what I'm saying? I mean, you add it all up. But anyway, it's a crazy long distance, you know. My friend Chris Beckstead gave a good analogy of if you took let's say the sun was a huge beach ball, and you know, here's your arms and it comes down and, well, whatever. But anyway, this huge beach ball that is big enough that you can barely hold onto with your arms. Sorry, that was retarded, but alright, the sun is this big, huge beach ball. And if the sun was a beach ball, then the earth would be like one of the tiny little marbles. And it would be like 3 or 4 blocks down the road. I mean, that's more realistic than the actual model we get. You know, on the standard model, you have the sun, and then you have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus and Neptune, Pluto. They don't call it a planet anymore, but I still do, so whatever. Anyway, it's kind of misleading, the distance scales, because really the distance between things in space and in our solar system and you'll see in the whole universe is insane. I mean, this distance right here, and it's actually about 150 million kilometers, which is just a crazy distance. I mean, that's insane. It's 150 million kilometers. And now we're actually going to jump up. We're going to jump up to the next level of measuring device, which is actually, because these numbers, kilometers, are just getting too big, so we're going to move up to astronomical units. And that's something they came up with so that they could just say this distance is equal to 1 astronomical unit. The distance from the sun to the earth is 1 AU. And it's actually right around 150 million kilometers. And it's a crazy distance. I mean, it takes light 8 minutes. Remember, 7 times around the earth in 1 second. It takes it 8 minutes to travel this distance. Alright, and now we're going to jump. We're just going to jump all the way out. We're going to jump all the way out to Pluto. And Pluto, which they don't call a planet anymore, but whatever. Pluto is actually about 39.5, I think, but we're just going to go ahead and call it 40 astronomical units. 40 times the distance from the Earth to the Sun. That's how far it is to Pluto. So you got your beach ball. Earth is about 3 or 4 blocks away. It's a marble. Pluto is like a fraction of a grain of sand. That's you know what I'm saying? That's what? Say we're 3 blocks at Earth, so we'd be 40 times that distance. We would be, what is it? 120 blocks away, and then you think about the fact that it's just this granule of like 1/100th of a grain of sand floating out in the middle of nowhere, 40 astronomical units away. It's roughly about 6 billion kilometers. 6, I don't know, that looks like a G to me, but 6 billion, is that right? Yep, 6 billion kilometers. That's how far Pluto's, and this is the furthest orbit that we consider, well, I consider a planet. 6 billion kilometers from the Sun to Pluto. And it takes light, let's see, 320 minutes. 320, so over 5 hours. It takes light, at the speed of light, a photon, over 5 hours to reach Pluto. So it's a crazy Just insane distance. So now we're going to go ahead and we're gonna shrink that down, and we're gonna just say that that distance is this circle right here. All right, and that will be the distance from the Sun to Pluto, and it's about 40 astronomical units. We can make it bigger. I don't know how good you can see that, but anyway, it doesn't matter. But out here, about 10 astronomical units further, would be the inner extent, the beginning of the Oort cloud. And the Oort cloud is actually just the dust and gas. It's what never kind of gravitationally pulled itself together, but it's still gravitationally held. This Oort cloud is gravitationally held to our star. And this actually goes out quite a ways, but so right here the inner extent is about 50 astronomical units, and then all this dust and all this matter that's out here that just kind of floats around outside, this is actually what we would consider, if we were looking from another star, let's say right here, Alpha Centauri, which is the closest star to us. If we were looking from this star, this is kind of what we would be looking at. We wouldn't just be looking at the very fraction of a dot in the center, which is the Sun, which is huge. We'd be looking at this entire Oort cloud, because it kind of glows, you know, and this is just pretty much everything encompassed by our star. It's everything that is gravitationally held, all our planets, all our asteroids, all this dust and extra material, and we're actually now we're going to jump up to the next unit of measurement, which is a huge jump, and it's in this distance right here is actually 1 light year. 1 light year. So everything that we would consider our star is actually 1 light year across. So a photon emitted from right here would take it a year to get to this side right here. Remember, it takes 1 second to go around the Earth 7 times. A year at that same speed to traverse everything we would actually consider our star. And what you're going to find out in the next videos is that this distance is nothing. I mean, it really is nothing. But let me clear up one misconception that a lot of people have about a light year, and that's that it's a time. A light year is not a time. A light year is actually a distance. A light year is just the distance light travels in 1 year. And it's actually pretty close to about 6 trillion miles. 6 trillion miles. Yep. Or kilometers, I'm sorry. Kilometers. Or maybe it is miles. I'm not positive. I could be wrong on that. I don't know for sure. But it's an insane distance. So yeah, that's pretty much what we consider our star and the end of this video.